Hey there, Algebra 1. Catlin here with your help for your cooldowns. I know we've been having some people out, so hoping these videos are helping you guys get through this stuff. I know it's better to be in class and discuss and be able to ask questions, but this is where we're at. So we're looking at lesson 8, exponential situations as functions, and we're looking at a beaver population. This graph is showing the population of beavers in a forest for different numbers of years after 1995. So 1995 would be here, and then it's almost like broken down by seasons. You can think like spring, summer, winter, fall, first year, so on and so forth as the years pass. So growing exponentially, the beavers are taking off, they're thriving, and we are to explain why we think of the beaver population as a function of time in years. So it's a function of time. So as a function of time, because time is independent and years are dependent. So we could say that because time is independent and the years are dependent. And because of that, that's why it's a function of time, because the time is independent. Anytime you have a function of something, what it's a function of is independent of what it spits out in the function, which is dependent of the population here. So how far the time has passed dictates how many beavers there are in the population. As the years pass, we see growth. Number two, what is the meaning of the point labeled Q in this context? So let's focus in here on Q. Q is this point here. In this context, this would be 3.5 years after 1995, right? And the beaver population looks to be slightly over 500, maybe 550. So the meaning of Q would be there are about, looks like 550 beavers mid-year in, okay, this is, if this is 1995, 96, 97, 98, in 1998. That's what 3.5 years after 1995 would be, mid-year in 98. So maybe like summer of 98. That was a good summer. You guys weren't alive yet, but I was in 7th grade. I was you guys' age, 7th, 8th grade in 1998. I'm old. Write an equation using function notation to represent this situation. Okay, so for this problem, we need to stick to our format for exponential growth because we have the curve. So we're going to do a times b to the x power, where a and b are in order the initial starting amount and b is the growth factor. All right, so we need a growth factor here. So let's look to the table, or let's look to the graph, sorry. So ignoring the x values and just going from y value to y value, we can clearly see that this is a double type of growth. So in the third year, we would expect 400, and there it is. It makes sense. So if we go in reverse to where it started, we would go back from 100, and the opposite of multiplying by 2 would be dividing by 2. And so in the year 0 in 1995, even though it wasn't clear to see, it's 50 because that's half of 100, and it's also halfway between this mark, which is representing 100, and 0. So it makes sense that this beaver population was 50 in 1995, and then it started to double from then on out. So if we have a starting point of 50, we're going to write 50 multiplied by our growth factor b, which is a double, 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 double. It's doubling every year. So times a 2 to the power of x. But we're not done because it says to do this in function notation. And I believe we get to come up with our variables here because they don't tell us what they are. So let's have fun with this. Let's call years y, so we can keep that as y. That doesn't have to change as far as the part of the function. And we'll call, so this, actually, no, let's do t for time. I don't want to put y on the x-axis. That's just going to confuse me. And then we can call the number of beavers b for the beaver population. Okay, so time and beavers population, those are our variables. And the independent variable here, time, is independent. And we can say that the beaver population is a function of time. So that sentence alone tells me b of t is the name of my function. Beaver population is a function of time. So we can replace our y there with b of t, right? We're going to call this beaver population as a function of time equals 50 times 2 to the t power. So it's the same math. It's just written in function notation now. Instead of x's, we replaced our x-axis with t for time. And instead of y for the y-axis, we're calling it the function b that is a function of time. So b of t. And there we go. That's the help for your cool down today. That's lesson number 8. Hopefully, we're getting better at these exponential equations and functions. And if you guys ever need any help, feel free to email or ask a question during the day while you're in class. I'd be more than happy to help. Love you guys. Later.